In this video, we will generate the cosine dataset, sine dataset, and the Taylor-Maclaurin series sum expansion of both using double factorial. We begin with the cosine dataset. So array formula, cosine of the x values 0 to 8. And the sine function, which is array formula, sine of the x values 0 to 8. And the Taylor-Maclaurin series sum, which is the summation of a times x to the power 2n plus k, where k is 0, 1. So data validation, list of items, 0 or 1. You can start with 0 if it is cosine, 1 if it is sine. And the value of n is 0 to infinity. 14 is good enough. Now the expansion coefficient. So array formula, minus 1 raised to the power n. And we'll copy these values of n because we're going to use that very often. Control C. Divided by, there are two parts. The first part is double factorial 2n plus k. So fact double 2 times n plus k. That's the first part. The second part, again, double factorial 2n minus 1 plus k. So double factorial 2 times n minus 1 plus k. And then enter. So at k equals 0, there's an error. K equals 1, there's no error. So we'll correct this error. So at n equals 0, this should be 1. So we'll correct this. So if n equals 0, it should be 1. Otherwise, calculate. Now it's corrected. So this is 1. So we have corrected it. Now we can complete the expansion, which is array formula, series sum of the x values. So x values raised to the power 2n plus k, where 2n plus k starts from k, incremented by 2n. So 2n is 0, 2, 4, 6, so the increment is 2. And the coefficient, it will be this range. And enter. So k equals 0, it's cosine. K equals 1, it is sine. Now we'll chart this. Insert chart. And we use scatter chart. Use row 1 as header. And the series show the trend line. Polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. And for the series again, the point size will be maximum. Except for the expansion, the point size will be none. But the line thickness will be maximum. So here's our trend lines and the polynomials, which we can toggle our values of k 0 or 1. So k equals 0, it is cosine. If it is 1, then it's sine. We'll calculate this polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. This is transpose 0 to 8. And the elements of the matrix array formula of the x values raised to the power 0 to 8. Now we calculate LINEST. LINEST starting with cosine. So data y and data x. Then the expansion. LINEST data y and data x. And finally the SINE, which is LINEST data y and data x. Now we can compare our polynomial regression coefficients with this. So coefficient of x to the 0, so we'd say this is cosine. So coefficient of x to the 0, 1, 1, 0. So 1, 1, this is 0. Coefficient of x, that's negative 0.0345, negative 0.0345, 1.07. Coefficient of x squared, negative 0.414, negative 0.1, negative 0.194. Coefficient of x cubed, negative 0.0795, 0.0433. Coefficient of x to the fourth, 0.0763, negative 0.119. Coefficient of x to the fifth, negative 6.44 times 10 to the minus 3, 0.0474. Coefficient of x to the fifth, 1.57 times 10 to the minus 3, and this is 7.38 times 10 to the minus 3. Coefficient of x to the 7, 2.72 times 10 to the minus 4, and 5.14 times 10 to the minus 4. Coefficient of x to the 8, 1.16 times 10 to the minus 5, 1.34 times 10 to the minus 5. If I toggle this to 1, k equals 1, then it is SINE. So these values are the same, and their data sets, they're also the same. If I toggle this to 0, it's cosine. So these values are the same, and these data sets are the same. This completes the use of Taylor-Maclaurin SERIESSUM in FACTDOUBLE, double factorial, to generate cosine and sine dataset.